Welcome to Day 8, Chapter 5. Today's topic is equation of parallel and perpendicular lines. Today we are going to be writing equations of parallel and perpendicular lines and talking about the relationships of them. I have, as you joined in here, already taken care of this first part here up in this box. I plotted the 2 points here that are on line A and made them red. I plotted the 2 points that were in line B, made them blue. Plotted the 2 points that are in line C, made them, we'll call it pink. The question that I read over here in number 1 is it says which lines intersect. Well, as I look at lines that intersect, they're talking about which lines are going to cross. And I can say that line A intersects line B. I see that happening right at this point here. I also can see that line C is going to intersect line A. When we look at these intersections, they're going to ask us a little bit about geometry here. They're going to be asking us here, what kind of angle? Well, we know when we talk about geometric angles, we have acute angles, we have obtuse angles, we have straight angles, and we have right angles. What we are going to recognize here is that these lines are going to be meeting in such a way that is creating a 90-degree angle. So the intersecting lines are meeting at a 90-degree angle, or what we talk about as a right angle. They're going to back us up here and they're going to ask us to consider finding the slope of each of these lines, and then we're going to try to create a relationship on these slopes. So if I look at line A, I know that line A is going to have a negative slope. If I count it out from the graph, it is negative 1/2. If I take a look at line B here, I'll change my color, is going to be going up 1, 2, 3, 4, 5, 6. Let me check that. 1, 2, 3, 4, 5, 6, and over 2. Which is going to be 3 over 1 as we adjust it. And please allow me to correct this here. That is not negative 1/2. If I count that out from the graph a little bit better, sorry, I was off by 1. This is over 3, so this is negative 1/3. Not negative 1/2, sorry, lost a tick mark in there. And then last but not least, we do want to count out line C. The slope on this one here is going to be 1, 2, 3, 4, 5, 6 over 2, which is again 3 over 1. Well, what the relationship that I see here is that line B and line C have the same slope. They were both going to be equal to, if we want to talk about M, the slope of line B was 3 over 1. The slope of line C was also 3 over 1. There is another relationship that's going to exist, but we're going to use number 4 to help us out on that. And it says focus on the intersecting lines. What is going to happen when we multiply the slope of each line by the slope of the other line? And it says what is the product? The product is the result of a multiplication problem. So if I take line A, the slope, which was negative 1/3, and I multiply with that by the slope of line B, which was 3 over 1, we know that as we multiply this out, this is going to be equal to negative 1 times 3 is negative 3. 3 times 1 is 3, which is going to equal negative 1. If we take a look here at, now we're going to consider the other lines that intersect. So this is talking about line A. Being multiplied by the slope from line C. When we multiply this out, we get negative 3 divided by 3, which is again negative 1. I'm going to put some labels back here on the first one here. This was line A, the slope of line A. The one that we had in blue here was the line B slope. But what we want to recognize here is that the product is negative 1, and this is going to come up here in our summarization down here at the bottom. So it says, let's summarize. And we are going to fill in the blanks here, and it says, lines that have equal slopes are parallel. So if they have the same slope or equal slope, then we're going to talk about those lines as being parallel. And then the next one here, we have to be careful, is that we're going to talk about lines that have opposite reciprocal slopes are what we talk about as being perpendicular. You've maybe heard of perpendicular. Perpendicular means that their intersection is going to form a right angle, or an angle that is going to measure 90 degrees. And as we calculated up here in number 4, when you find the product of their two slopes, that product is going to be equal to negative 1. We may have to talk a little bit in here about, I'm going to pick a color that will maybe differentiate this. Opposite is positive versus negative. And when we talk about a reciprocal is going to be talking about like A divided by B as compared to B divided by A. So you're going to flip the numerator and denominator. So here we get into opposite reciprocals. One more time if you missed that. Reciprocals are A divided by B versus B divided by A. Opposites, we said, are a positive number versus a negative number. So what we want to do here is answer the question here. What is the opposite reciprocal of negative 4 divided by 5? Well, if the first one's negative, the second one's positive, and we flip the 4 and the 5 to call it 5/4. Problem number B. 1b here says, what's the opposite reciprocal of 5? I'm going to write 5 as a ratio of 5 over 1. If that is positive, this answer down here will be negative, and then we flip the top and the bottom. In letter C, if the first one is negative, the second value here must be positive, because we're talking about opposite reciprocals, and that's 9 divided by 1, or what we can just talk about is the number 9. Letter D, opposite reciprocal. If the first one's positive, the second one is negative, then take the reciprocal and flip 2 and 7. So that's negative 7 halves. And again, I'm going to write negative 4 as negative 4 divided by 1, so that when we talk about the opposite will be positive, but the reciprocal of negative 4, or negative 4 divided by 1, is 1/4. Here we want to do about a little bit of comparison, and they give you a statement here that says, if the lines are perpendicular, what is the slope of the second line if you're given the slope of the first? Remember back here at the top that we said we are looking for opposite reciprocal slopes when we are talking about perpendicular lines. So let's take a look here at these. If this is slope of the first line is 2/5, well, that's positive. We know that the other line must have a slope that is the opposite, so now negative 5 divided by 2. If we take a look at letter B, again, we have a positive slope to start. I'm going to write it as 1/1, which is equivalent to that 1. But if the first line is positive, the second line is going to have a slope that is negative 1 divided by 1, which is just the number -1. The last example here gives me a slope that is -2. And when they give me that slope that is -2, I'm going to write it as -2 divided by 1. And then the opposite reciprocal is now going to be positive. Flip the numerator and denominator, that's 1 divided by 2. When we look here at number 3, we did some problems like this earlier when we were just determining whether or not two lines were parallel. But remember, parallel is going to give me the same slopes. Perpendicular is going to give me the opposite reciprocal slopes. And if they're not parallel and they're not perpendicular, that would be like the neither case. But in order to do any of this, we do need to make sure that we are first determining the slope. So I'm going to call this one line A. And if I take a look at y equals 2x minus 5, I recognize that this is a y equals mx plus b form, which that would give me the slope here of this first line as being 2. When I take a look at line B, well, line B is starting out for me not in slope-intercept form. This is starting out in something that is called standard form. So in order to put this in slope-intercept form, I'm going to work to isolate the 4y, so I get -2x plus 28 on the right side by subtracting over that 2x. And then I divide everything through by 4, do a little bit of reducing, and I get y is equal to -1/2 x plus 7. This is now in slope-intercept form. Because this is in slope-intercept form, now I can state the slope of this line is -1/2. Here is where we make that comparison. If line A has a slope of 2 and line B has a slope of -1/2, our conclusion is the two lines are, we take a look at 2 and -1/2, those are going to be opposite reciprocals. And we can provide the reasoning and say that the two lines are that's not spelled perpendicular. Perpendicular, because the slopes were opposite reciprocal. Another way you could have stated this conclusion is you could have stated that the product of those slopes was going to be equal to -1. And we get down here to the bottom, and it says determine if any of these lines are parallel or perpendicular. Note, in order to do this, you need to first find the, yes, the correct answer is you got to find the slope of each line. So line A is already in y equals mx plus b form, so I know that my slope of this line is 5, or 5/1. The second line here is in standard form, so I need to subtract x. 5y is equal to -x plus 2 divided by 5. And we get here -1/5 x. Note that that's a 1 in front of there, plus 2/5, which is telling me that the slope of this line is -1/5. And last but not least here, we're going to add over 2x. Divide by -10. Simplify -2/10, and that is going to be -1/5 times x. Slope of this one here is -1/5. Well, let's cover the easy one. It asks us here which lines are parallel. Well, if we're going to talk about parallel lines that are parallel, are be the ones that with the same slope. So we can say line B and line C are parallel. And that is because m sub b is equal to m sub c. So that's meaning that the slope of both those lines is negative 1/5. We can make a second conclusion, and that second conclusion is that we can state that we have some lines that are perpendicular, and that is line A is perpendicular to line B because, again, we can state because they have opposite reciprocal slopes. I'm going to just say because they have opposite reciprocal slopes. Well, I'm not going to go back and rewrite this whole thing again, but there is one more statement we can make, and that is that line A is perpendicular to line C and also perpendicular to line C. And again, I won't go through that same reasoning. We just discussed that reasoning, but it's related to that idea that those are opposite reciprocal slopes. Positive 5 is related to negative 1/5 are in fact opposite reciprocals. All right, last page here. It says, can you write an equation of a line that is going to be parallel or perpendicular? I would say keep your work organized here. That will be half the battle. So here we're going to pass through a point. And we want it to be parallel to this line. Well, let's remember that this line is going to be in y equals mx plus b form. So my slope is equal to 3. If I want to talk about the line that is parallel to this, I'm going to also use a slope of 3. I'm going to use this notation to represent the parallel slope. So if I want to write my equation, let's think about this here. Given a point and the slope. Remember that we're going to write it in point slope form. And as I do this, it's y minus this y coordinate here, which was negative 5, equals the slope that they gave me was 3. And I'm going to keep the same slope because it's parallel. And then it's x minus this x coordinate here, which was a negative 3. We're going to recognize some double negatives there. Answer here would be y plus 5 is equal to 3 times parentheses x plus 3. Let's be aware here as we look at example or problem 6. Here's my point. And we want it to be parallel to this line. But let's be careful here. That line is not in y equals mx plus b form. So the first thing is we have to do some computations to convert this to y equals. So what I'm going to do here is I'm going to subtract over 4x. I'm going to divide by negative 1. I get y is equal to 4x minus 7. And that is going to tell me that the slope of this line is 4. Again, we double check the keyword here is parallel. So the parallel slope I'm going to use is, parallel slope I'm going to use there is still 4. Again, given a point and the slope, we're going to start in point slope form. If I write this in point slope form, it's y minus the y coordinate equals 4 times x minus the x coordinate, which was also 4. And there we have it. In problem number 7, it It says write the equation of line that passes through this point. And again, we are being told we have a point. Well, when we are given points, we're going to start with them in point-slope form. But now we want it to be perpendicular to this line here. Let's be aware that this is in slope-intercept form. So the given slope here is -1. But if I want to talk about the line that is perpendicular, well, I'm going to represent this notation as a perpendicular slope. So the opposite reciprocal of -1 is positive 1 over 1. And again, I'm going to put a note here. M with that upside down capital T is going to be representing the perpendicular slope. And again, that I use for notational purposes so that when I come back over here and I say, all right, here's what I have. I got a slope of 1. I have a point, which was -211. And as I write this in point slope form, I don't get confused on which slope I should be using. Here's a y-coordinate. Equals 1 times, this is x, minus that x-coordinate, which is y minus 11, equals 1 times x plus 2. Let's take a look at the next example. It says, can we write the equation line that's going to pass through 4, -5? Again, we have a point. And is perpendicular to this given line. Ooh, we take a look at this given line and say, hold up. This is in point slope form. But if it's in point slope form, can we still state the slope? And we should recognize that the slope here is 2. I do want to recognize that this problem's not asking me for the parallel line, it wants the perpendicular. So the perpendicular slope I'm going to use is the opposite reciprocal there, which is going to be -1/2. If we are given a point and a perpendicular slope, when I write my function here, I'm going to be writing it in point slope form. As we substitute those values in, it's y minus, that's -5, equals a slope of -1/2 times parentheses x minus 4. I'm going to be aware here of double negatives, so that's y plus 5 equals -1/2 parentheses x minus 4. And one more to go here. Example number 9. We are going to again recognize that they are giving us a point, x sub 1, y sub 1, and we want it to be perpendicular to this line, but notice this is in standard form. When something is in standard form, that's not going to tell me my slope. What I need to do is convert it to slope-intercept form so I can calculate the slope. So I'm going to subtract 9x to both sides, divide by -3, divide each term by -3, and we're left with y equals 3x minus 12. That tells me that my slope here is 3 for the given line. Read carefully. It says we want the perpendicular line. So the perpendicular slope I'm going to use is the opposite reciprocal of 3, which is going to be using a slope that is perpendicular being -1/3. Again, we have a point and we have a slope. When we have a point and a slope, we're going to start in point slope form. As I write this out and substitute in, it's y minus the y-coordinate, which was -11, equals my slope, which is over here, -1/3, multiplied by x minus 7 in parentheses. Again, double negative there is y plus 11 equals -1/3 times parentheses x minus 7. And there is your equation of the line that is perpendicular and passes through 7 and -11. And that is a wrap here for day number 8 notes. Next up is to work on your homework.